Hey everyone, my name is Hillary Melton and I'm currently a student at Johns Hopkins University getting ready to finish up my master's in Geographic Information Systems, or GIS. I had Paul Daugherty as a professor for my GIS for Emergency Management class, and he was kind enough to agree to be my mentor for my final thesis project. I'm working with him and the MRA on their mission data collection project, where I've been learning about the integration of Search and Rescue in GIS. I created a short survey using an ArcGIS tool called Survey 123 that was then sent to MRA's Search and Rescue teams as a way to learn their thoughts on using GIS and what experience they have with it on their teams. One question asked what challenges they can think of in increasing the use of GIS in Search and Rescue. Their ideas, which may be unsurprising to all of you, include the lack of training, access to hardware and technology in the field, and the amount of time it takes to use the technology during or after an incident. My hope is that by working on this project, I can decrease some of the time and effort it takes to use GIS in search and rescue operations by promoting the importance of the pre-planning stage of data preparation. Creating minimum essential datasets saves time going into an incident as well as providing the most recent geographical data instead of relying solely on paper topo maps that could be outdated. I'd love to show you how easy it is to add layers of data to a web map on ArcGIS Online. Here, I'm logged on to MRA's ArcGIS Online. The first way that base data can be added to a map is by uploading the layers directly into your ArcGIS Online account. This can be time-consuming but beneficial if you have data that is being used in ArcGIS for desktop and you want it available for use on ArcGIS Online. This is showing a list of layers that I individually uploaded for a national minimum essential dataset, which includes various national layers such as airfields, counties, and wilderness areas. Once the data has been uploaded to ArcGIS Online, you can click on a layer and add it directly to a map by clicking Open in Map Viewer, which will then look like this. Or, if you are on the home page and you click on New Map, you can search for the layer in your organization by using the Add button seen here. Since I labeled each of the national layers as BD for base data, I can just type in BD, which will then list all of the national layers that I uploaded, and then I can add the layer directly from there. There are a couple of other ways to add data that are easier than individually uploading each layer. You can also use the Add button to search for publicly made layers on ArcGIS Online. By changing the search parameters from My Organization to ArcGIS Online, you can find data uploaded by other users or organizations. For example, searching for Maryland US routes provides us with a data layer uploaded by Maryland's Mapping and GIS Data Portal. Now that I've added the counties and the US routes for the state of Maryland, I've decided that I want to get rid of this blue color that's filling in for the counties so that I can still see the topographical map underneath. To do this, I click Done Adding Layers, and then I hover over the counties layer here, and I choose this icon that says Change Style. Then I click Options, click on the Symbols button. I make sure that Fill is chosen, and then choose this box, which is no color. Then I click OK, and the changes appear on the map. Now just make sure that you click OK and Done for the changes to save. Another technique to add a data layer is by using a web address. Maryland has an excellent GIS data portal with many data layers in varying categories to supplement your mapping needs. Here is a layer for local transit routes in Frederick County. I've decided that I wanted to add this to my map along with the US routes added directly from ArcGIS Online. Instead of going back to the map and searching for it from there, I can scroll down to where it lists the source address, right-click, and then copy the link. Then head back to the map on ArcGIS Online, click this Add button, add layer from Web, paste the address here, and then click Add Layer. Then it will show up in your contents, and by clicking this button here for more options, if you click the Zoom to button, it'll zoom in on that layer so that you can see it a little better. If you continue to add layers of data relevant to your interests, you can end up with a minimum essential data set such as this example that was created for the state of Maryland. By saving all of the layers into one web map, it makes it really easy to keep all of the data for the minimum essential data set together. The map can then be personalized depending on what it's being used for. If you look at the contents pane here on the left, you'll see that I have a few visibility levels set for this map extent, so that when the map is zoomed out like this, you aren't too overwhelmed by data. Then, as you zoom into the county level, more layers are made visible. Now that I'm focused on this portion of Frederick County, we can see hiking trails in brown, U.S. routes in red, local roads in gray, cellular towers, airfields, and streams and rivers in blue. To set a visibility level for a layer, click the More Options button, set visibility range, and then from there you can use the slider bar to determine at what extents this layer is visible. We can also choose to turn off some layers and turn others on depending on what data is needed. For example, I will turn off local roads and U.S. routes and turn on this layer of land use land cover, where we can assess the terrain and physical properties of the land surrounding this municipal forest and its hiking trails. The data provided in a minimum essential dataset can also be used during and after search and rescue operations. Instead of using GIS only as a means of documenting where an incident has occurred, we can use the data collected during an incident and combine it with the data provided in the minimum essential dataset to analyze possibilities of why the incidents are occurring where they are. This might include terrain analysis of slope, elevation, and aspect, as well as relational factors like distance from cellular towers or distance from the initial planning point. The more we understand why these incidents may be occurring, the better we can equip our teams as they search for lost persons in the field. I hope this demonstration has given you a better idea of the importance of keeping updated layers of base data in addition to paper topo maps as we pre-plan for search and rescue incidents. Thank you for your time, and if you would like to see more examples of what GIS can be used for in search and rescue, mapsar.net and ysarandgis.blogspot.com have some great resources and additional demonstrations to check out. Thank you.